Good morning, students. My, my voice is audible?
Yes, sir.
Okay, thank you. Today, first 15 to 20 minutes, I am going to uh, solve some of the problems in the equation reducible to standard form. Just I am going to give the idea only for the remaining problems. And you try to solve. If you have any doubt, you can ask me later. Okay, now, first problem, solve px pqxy. Okay, pqxy is equal to z square. So how to solve this problem? If you know the idea, you can tell. Otherwise, I will give a suggestion or idea. You can solve this problem by two different methods. The first method is if you divide by z square, you will get pq xy divided by z square is equal to 1. And then you can write this is px. Usually I told that z is grouped with p and x. Similarly, x is grouped with p and y is grouped with q. So that's why I write like this: q y by z equal to 1. Okay, now if after writing this, you can see that the power of p is 1 and the power of q is 1. And also you can write this is x into z power minus 1 into p into y into z power minus 1 into q equal to 1. Okay, now the power of p is 1 and the power of q is 1. Now you can find the value of m and k. M equal to, please tell, m equal to what?
1.
Yeah, m equal to 1, n equal to 1.
1.
Yeah, k equal to
Minus.
minus 1. Okay, now what is the substitution? Capital X is equal to
Log x.
capital X is equal to log X and the capital Y equal to
Log y.
log Y. Okay, and then capital Z equal to
Log z.
small z. Okay, yes, correct. Thank you. And then you need to write the partial derivatives and okay, but I'm not going to that part now because you need to practice some of the problems. After I call usually this is equation 1. Equation 1 is same as the given problem. Okay, from the given problem I rewrite the equation 1. Okay, now after writing the partial derivatives, usually we will write this equation 1 implies something in terms of capital P and capital Q like this. Okay, now the equation 1 transformed into which type? F of, can you guess which will you can convert which type?
Capital P, comma, capital Q.
Yeah, capital P, comma, capital Q. Yeah, equal to 0. Here, I missed some steps. So you need to solve here. Okay. So this is the, f of P, comma, Q. Okay, I'll just give the final answer. And f of P, comma, Q. Okay, I will give the, you get actually PQ equal to 1. Okay, you will get PQ equal to 1. So that is f of p comma q. This is equation 2. So the final answer for this problem is log small z equal to a log x plus 1 by a into log y plus c. Okay, now second method. So you can keep this z square as it is. Okay, so method 2. So you write p into x and q into y equal to z square. Okay. Now here p is power 1 and q is power 1. So you can find the value of m equal to 1 because it's a power of x, and m equal to n equal to 1, and z is the other side. So z is not with p and q. So then there is no need to, you can't find the value of k. So now if m equal to 1, capital X is equal to, this is actually equation 1, capital X is equal to log x, okay, capital Y equal to log y. Now again you should write the partial derivatives. Okay, now the equation 1 is transformed into which form? F of p comma q comma z equal to 0, and you should solve this equation. This is type 4, and you should but you not get the same answer, but you will get a different answer, but that is also correct. So this is a method. So you should try to solve this problem. If you have any doubts, you can ask in the group. Okay, second problem. Solve z square into p square plus q square equal to x plus 1. So if you know how to solve this problem, you can tell, because we solved nearly 8 to 9 problems. I'm just asking the hint. There is no need to give the entire solution. How to start? Okay. So if you multiply, yeah, please tell. Somebody is,
We can write z plus p whole square plus z plus q whole zq whole square
yeah, it's a p square. Okay, correct.
plus zq whole square.
Okay, equal to x plus y. Then you can tell m and n value also. Yeah, you can't. Sorry, you can't
K
tell
value.
Yeah, k value. Yes, you are right. K value equal to what?
1.
1. Yes. So because x and y are separated, but x and y are not with p and q, so you can't find the m and n value. If k equal to 1, what is capital Z?
Z square.
Yeah, Z square. That is Z power 1 plus k. So Z power 1 plus 1. So Z square. Okay. Now you should write the partial derivatives, and this is equation 1. So after this equation is of the form f of what? Which form? Out of 4 types, standard types.
Type 4, sir.
Type 4, yes. Capital P, capital Q, and x comma y. Okay, So usually we will call equation separable type. Okay, equation separable type. F of p comma q equal f of p comma p and x are one side and q and y are the other side. Okay, so this is reduced to the separable equation. Separable equation. So, okay. So now I will just give the final answer for this problem. You can verify later. Answer for this problem is separable equation is, I will give a separable equation also. Capital P by 2 whole square plus capital Q by 2 whole square equal to x plus 1. So answer for this problem is z square equal to 4 by 3 into x plus a whole power 3 by 2 plus 4 by 3 into y minus a whole power 3 by 2 plus b. Now third problem, p square plus x square y square q square equal to x square z square. So first you should find out this is not comes under first 4 types. So that is very important. This is function of this is not a function of p and q. Okay, this is not function of this is not in the form of Lagrange equation. You know the general form, and you should eliminate like this because we are solving last 2-3 classes equation reducible to standard form. Then you know that this problem is comes under equation reducible to form. Suppose in the examination, if you see this problem, it is little bit difficult to identify this problem is comes under equation reducible to standard form. Okay, for this you need practice and also how to eliminate. You should know all the type. Okay, and you should write down. Okay, this is not comes under the first type like this. Okay, and then this is not comes under Lagrange equation. This is not comes under ZPQ or XPQ, YPQ. Okay, because here you have all the 5 variables. If X, Y, P, Q, Z, then it should be Lagrange form. If it is not Lagrange form, then it should go to equation reducible to standard form. Surely this is not a Lagrange form. You know that Z equal to Px plus function of P and Q is what? Lagrange form. So and hence this should be equation reducible to standard form. Okay, now what is the first step? If you do this step, then only you can solve this problem. Otherwise,
Divide by x square z square.
very good. Divide by x square. Yes, because I told that x is always with the p, but here x is with the q. So that's why first you should divide throughout by x square. So p square by x square plus y square q square equal to z square. Okay, now you can write this is x inverse p whole square plus yq whole square equal to z square. So this is equation 1. Okay, now here m equal to -1 and n equal to 1 and z is separated. So now what is capital X? Capital X is equal to x power 1 minus m. So x power 1 minus of -1 is +1. So x square. So and then if n equal to 1, capital Y equal to log y. So capital Y, but z is separated. So there is no need to find k value. So after finding the partial derivatives, you will get this form. Okay, so you'll get 2 capital P square plus capital Q square equal to Z square. This is equation 2. Now, if you solve the final answer, okay, I'll give the final answer also. Root of a square plus 4 into log small z equal to x square plus a log y plus b. Okay. So next problem. Problem number 4. So here you should try this problem. X power 4 p square minus y z cube minus z square equal to 0. I think for this problem, there is no need of for hint. You should try this problem. Just give the answer. You can solve again this. Okay, you need a hint for this problem. Okay. What's the first step again?
Dividing whole by z square.
Yes, yes, very good. Dividing first step, divide by, because z is with y, but z is not with x. So that's why I divide by z square. Divide by z square. Then x power 4 p square by z square. So you divide by z, I think you will not get in the correct form. Here you will get z, here you don't get z. Okay, again you have a problem. Okay, so it is better to divide throughout by z square. Then here also z, here also you have z. Okay, if you divide by z square minus y z cube by z square equal to z square by z square is 1. Now you can write this is x square z power minus 1 p whole square minus this is actually y z power minus 1 q, because after cancelling you have 1, so I will write z in the numerator. So y z power minus 1 into q equal to 1. Now p is power 1, q is power 1. You can write m value is power of x 2, and the n value is power of y 1, and the k value is minus 1. Okay, now the substitution is capital X equal to, please tell, x power 1 minus m equal to x power 1 minus m is 2, so x power minus 1, and the capital Y equal to n equal to 1 means capital Y equal to log y, k equal to minus 1 means capital Z equal to log Z. Okay, now the equation 1 transformed into function of p comma q. That is the first type. P square minus q equal to 1. You can verify later. So the solution for the given problem is log z. I'll write here log z equal to a by x plus a square minus 1 into log y plus c. Okay. So next problem, z power 4 q square minus z square p equal to 1. Okay. Here you have zpq. Yes, here we have Z PQ. Okay. Uh, so why we can't solve this problem in type 3? Because type 3, you have ZPQ and XPQ and YPQ. So somebody will try this problem in type 3. So whether you are, if you don't get the answer, then we will solve this problem by equation reducible to standard form. So sometimes equation reducible to standard form is easier than standard form. Okay, because we can easily convert this equation into type 1. If you convert into type 1 is easier than type 3. So then you can easily solve. So here, if you write this is z square q whole square minus z square p equal to 1. Here power of p is 1 and power of q is 1. And hence k value is 2. K value is 2. Then capital Z equal to z power 1 plus k. So z power 3. So, and hence this equation 1 is transformed into first type function of p comma q equal to 0. So the final answer for this problem is that q equal to ax plus or minus root of 3a plus 9 into y plus some constant b. Okay. So sixth problem. Solve z square into p square by x square plus q square by y square equal to 1. So here we have all the 5 variables. So if the problem contains all the 5 variables, means it is Clairaut's equation. If it is not Clairaut's equation, then it is better to solve that problem by equations reducible to standard form. So this is not Clairaut's form. Then you can write this problem is Z x power minus 1 p whole square. Similarly, Z y power minus 1 q whole square equal to 1. Here power of p is 1, power of q is 1. So m equal to minus 1 and n equal to minus 1 and k equal to 1. So I don't give a substitution. So this equation is transformed into function of p comma q equal to 0. The answer for this problem is z square equal to ax square plus or minus root of 1 minus a square into y square plus b. Okay, I'll give 2 more problems to you. You try to solve. 7. Solve p by x square plus q by y square equal to z. So how to solve this problem? What is the first step? So you can solve this problem in 2 different methods. One is if you divide by z, the right hand side is 1. You divide by z, you'll get p into z power minus 1 into x power minus 1, x power minus 2, okay, x power minus 2, and plus q into z power minus 1 into y power minus 2 equal to 1. So here capital first m and m. What is m? Minus 2, and n is minus 2, and k is minus 1. So now this is reduced to function of p and q. Okay. Suppose if you keep z right hand side, if you don't divide by z, then you'll have p x power minus 2 plus q y power minus 2 equal to z. Now in this case, you have m equal to minus 2 and n equal to minus 2. For k, there is no need to find the value of k because z is separated. So this equation is transformed into function of p, q, and z equal to 0. So last problem. For z square q square equal to y minus x plus 2 into zp. So if you know how to solve this problem, you can give the idea. So here you can see y and the x are separated. Y and the x are separated. You have all the variables, I think so. X, y, z, p, q. So this is not a Clairaut's equation. So and hence this is equation reducible to standard form. And y and the x are separated. So that is also hint for us. And here you can write this is 2 zq whole square, because you should write you should keep z q power 1. So and then similarly this is minus 2 z p equal to y minus x. Here q is power 1 and p is power 1, and x and y are separated. So there is no need to find the m and n. Only thing you should find the value of k. So k is z power. So z power is 1. So k equal to 1. When k equal to 1, so capital Z equal to z power 1 plus k. So z plus z power 2. So now this is equation 1. So this equation is transformed into equation separable equation, function of pq xy. So separable equation. So try to solve these 8 problems. Okay, now I'm going to give some introduction about linear PDE of Lagrange's equation. Linear partial differential equation, Lagrange's equation. Okay, so a PDE of the form capital P small p plus capital Q small q equal to capital R, okay, is called Lagrange's linear equation. Is called Lagrange's linear equation. Here, here capital P and capital Q and capital R are functions of x, y, z. Functions of x, comma, y, comma, z. And you know that small p is rho z by rho x, and the small q is rho z by rho y. So actually, we have seen Lagrange's equation when we eliminate the arbitrary function. Okay, uh, arbitrary function. For example, I will give you. I think we solved this problem. If you have uh, uh, the class notes, you can check it. Okay, so this is the example we solved already. So eliminating the arbitrary function, the arbitrary function f from f of x square plus y square plus z square and ax plus by plus cz equal to 0. So if you eliminate, you will get the PDE cy minus bz into p plus az minus cx into q equal to bx minus a. So now this is the Lagrange's linear equation. So this is actually capital P. Capital P, small p. This is capital Q, small q. This is capital R. So now we are going to solve this PDE and we are going to get this solution. This is the solution of this partial differential equation, linear partial differential equation, Lagrange type. So the solution usually of the form f of, this is u, f of u comma v equal to 0. Okay, already in the elimination of arbitrary function, the solution is given. We form the PD. Now the process is reverse. Okay. So therefore, f of u comma v equal to 0. Actually, this is f of u comma v. This is u, this is v. So f of u comma v equal to 0 is the general solution of the Lagrange's equation. The Lagrange's equation is Pp plus Qq equal to R. So we call this is a general solution because here we have the arbitrary function. That's why we call this is a general solution of this Lagrange's equation. Okay. So now working rule. Working rule. To solve the Lagrange's equation, P small p plus capital Q small q equal to R where you know that P capital P and capital Q capital R are functions of x, y, z, and small p is dou z by dou x, small q is dou z by dou y. So step 1. one. Form the auxiliary equation or subsidiary equation. First, you should form the auxiliary equation or subsidiary equation. Okay, so dx by capital P equal to dy by capital Q equal to dz by capital R. Actually, this is Lagrange's subsidiary equation. Lagrange's subsidiary equation. Step 2. Solving the auxiliary equation. If you solve this auxiliary equation, you can find the two independent solutions, namely u equal to a and v equal to b. Solving the above auxiliary equation, find two independent solutions. So independent solution. Independent means one solution is not derived from the other. Two independent solutions. U is a function of x, y, z equal to a, and b of x, y, z equal to b, where a and b are arbitrary constants. Where a and b are arbitrary constants. And then step 3. Then the required solution is of the form the required general solution. Required general solution is f of u comma v equal to 0 or u equal to function of v or v equal to some other function of u. Okay, the required solution is any one other form. Function of u comma v equal to 0 or u equal to function of v or v equal to some function of u, where f, phi and g are arbitrary function. F, g, f phi, g are arbitrary functions. Okay. Now, so we need one more note. The subsidiary equation can be solved by two different methods. One is method of grouping and the method of multipliers. The subsidiary equations can be solved by the method of grouping and grouping. Another method is the method of multipliers. Method of multipliers. Okay, method of grouping is a little bit easier than method of multipliers. Sometimes if you can't uh, uh, use method of grouping, you need to go for method of multipliers. Now I'm going to explain the method of multipliers. If the subsidiary equation dx by capital P equal to dy by capital Q equal to dz by capital R, then by property of ratio and the proportion, then by properties of ratio and proportion, we have each ratio is equal to, that is dx by p equal to dy by q equal to dz by r equal to each ratio is equal to L into dx plus m into dy plus n into dz by L into capital P plus m into capital Q plus n into capital R. That is, we are multiplying L, numerator and denominator. Similarly, we are multiplying m, here numerator and denominator. Here multiplying by n, the numerator and denominator. So, where L, m, n may be constants, or functions of x and y, or functions of x, y, z. Are called, the LMN are called Lagrange's multipliers. Okay. Next, how to choose LMN? Okay, if LMN are found in such a way that you should find LMN in such a way that the denominator should be equal to 0. So that is LP plus NQ plus NR equal to 0. If the denominator is 0, then dx by p equal to dy by q equal to dz by r equal to L into dx plus m into dy plus n into dz divided by 0. From this, you can say that the numerator LDX plus MDY plus NDZ equal to 0. So only thing is you should choose L, M, N such a way that the denominator of this is equal to 0. So such a so if L, M, N are found in such a way that LP, that is the denominator, LP plus MQ plus N capital R is equal to 0. Then the numerator L dx plus M dy plus N dz equal to 0. So if you integrate, integrating this equation, okay, we get one solution. We get one solution. U of x comma y comma z equal to a. Similarly, we can find another set of independent multipliers. Independent multipliers LMN or using grouping method to find the another solution. Another solution we call D of x comma y comma z equal to D. Okay. So then the general solution is is f of u comma v equal to 0. So this is the procedure to find the solution. But the advantage of Lagrange's method is we are finding the general solution. But in the previous method, some of the methods you can find that. I think for all the methods you can find the complete solution. But for some of the methods only you can find a single solution. But for all the methods, I explain how to find the general solution, but we can't find a general solution. Eliminating these two, eliminating the parameters from the above two equation, we can find the general solution. So similarly, I stop. But the advantage of linear Lagrange's equation is you can find the general solution of the given PD. Okay. So now at least we'll solve one problem. Solve x square p plus y square q plus z square equal to 0. Okay, again, you see that you can hear all the 5 variables are here: x, y, z, p, q. This is not comes under Clairaut's form. Next, is it possible to solve this problem by equation reducibility method? Okay, you can solve this. Yeah, please tell.
Dividing whole by z square.
Yes, you are right. Dividing whole divided by z square. You can solve this problem by equation reducible to standard form. Or if you don't divide by z square, you keep z square right hand side, then the equation reducible to standard form 3. It is a function of pqz. Okay. But this problem I am going to solve by Lagrange's equation. So similarly, you should think for each problem. Okay. Now, solution x square p plus y square q equal to minus z square. Because the general equation of the uh, Lagrange's form is what? Pp plus qq equal to r, which is of the form capital P, small p, capital Q, small q equal to r. So here P is x square. Here capital P is x square, and capital Q is y square, and capital R is minus z square. Okay. Now auxiliary equation or subsidiary equation. Auxiliary equation or subsidiary equation is dx by p. Dx by p is x square equal to dy by q. Q is y square equal to dz by r. R is minus z square. You can check it. So now I am going to consider these two ratios. Consider. So dx by x square equal to dy by y square. So now if you integrate, you get integration of 1 by x square is minus 1 by x equal to integration of 1 by y square, dy by y square is minus 1 by y plus some arbitrary constant a. So this implies a equal to minus 1 by x plus 1 by y. So actually this is actually u. I told that we get the solution u equal to u of x comma y comma z equal to a, and b of x comma y comma z equal to b. So now we got the one solution. Finally, the general solution is of the form what? F of u comma v equal to 0. So now here a is nothing but u of x comma y comma z. Okay. So we got a. So this is u of x comma y. And then if you consider these two, even you can consider the first and three also. Dx by x square equal to dz by minus z square. So consider dy by y square equal to minus dz by z square. So integrating you get minus 1 by y, minus 1 by y equal to, if you integrate this, minus of minus 1 by z plus 1 by z plus b, this implies b equal to minus 1 by y minus 1 by z. Now the general solution is hence general solution is f of u comma v equal to 0. So here f of u is minus 1 by x plus 1 by y, and v is minus 1 by y minus 1 by z equal to 0. So if you want to verify whether this is a correct answer, the only way is we need to eliminate the arbitrary function we discussed earlier. Okay, you will get the given problem. That is the only way you can check it. So this x square p plus y square q plus z square equal to 0. Now second column, solve x z p plus y z q equal to xy. Okay, now here capital P. Okay, before going to Lagrange's type, again this is actually, you can check it what P, Q, X, Y, Z, everything is here. Okay, and this is not Clairaut's form. This is not Clairaut, sorry, yeah, Clairaut's form. Is it possible to solve this problem by equation reducible to standard type? You have here Z is along with the P and X, and Z is along with the P and X. You will have XY. So it's also here. So I think this is little bit difficult to solve this problem by equation reducible to form also. But here you have P, here have Q, okay, and this is R, okay. This is capital P, X is Z, and this is capital Q is what? Y is Z, and capital R is XY. So then you can solve this problem by Lagrange's linear equation. Then the auxiliary equation is dx by P.
Sir,
Yeah, please
sir,
tell. Yeah.
sorry to interrupt, but we have another class, sir, at this time.
Oh, 46. Okay.
Yes.
Okay. Then we will solve this problem next class. Okay. Okay. Thank you.